Topic modeling with large language models has never been easier. With the rise of Llama 2, open source LLMs are starting to become more and more competitive. They are nearing the performance of ChatGPT. In this tutorial, we will be using Llama 2 for topic modeling, where we go from thousands of documents to just a few interpretable topics. We will be using BERTopic, a highly modular topic modeling framework, on top of which we can use Llama 2 to derive topics to natural language. So without further ado, let's just get into it. What we have here is a Google Colab notebook. And the notebook shows all of the code that we will be going through in this tutorial. You will find the link of it in the description. But let's start at the beginning. What is BERTopic? Well, BERTopic is a topic modeling framework that allows us to go from documents to just a few interpretable topics, and they are generally represented through keywords. The approach that we're typically using in BERTopic is that we cluster the documents into semantically similar clusters of documents. And when we have those clusters, we assume that each of those clusters contains a single topic, of which we extract a number of keywords to try to represent it. So if you have a topic about cars, you can have the keywords car, cars, Ford, etc. And that by itself is very interesting and extremely helpful to understand what the topic is about. But you still have to interpret it yourself, right? I mean, if you have the words car, cars, Ford, you have to think about what the topic means. And that thinking about, we want to prevent. Not entirely, of course, but we want to make it easier to interpret those. And that's where Llama 2 comes in. So when we have those weighted words generated through CTF-IDF, we basically give them to Llama 2 along with some representative documents and ask Llama 2, okay, can you create a very interpretable label for this topic? So instead of the word car, cars, Ford, it might be this topic is about electric vehicles, for example. So there are many ways that we can represent the topic, but Llama 2 makes the interpretation of such a topic much, much easier. Now, we have this notebook, and to run all of this, we will need to make sure that you have a GPU. Typically, you can choose a T4 inside of Google Colab Pro, but if you go the CPU route, this will all become very difficult. Now, we will start by installing a few packages. Of course, BERTopic for the topic modeling. We will install datasets to make sure that we can load in the data that we're interested in, and then a few packages that make sure that we can run Llama 2 more easily on the GPU that we have. Because those large language models, well, it's in the name, they're quite large, and we want to make sure they can fit into the virtual RAM of our GPU. But as always, let's just start at the beginning at the data that we have. So I've already loaded in most of the things that we're going to do. I've also already trained the model. So we're skipping over a lot of boring training stuff. But the data that we have are archive papers, and more specifically, the abstract of those papers. And those abstracts are a perfect introduction into topic modeling in general because they contain nicely written text. They are very short, which generally helps with embedding models, and they contain all of the information that you're interested about. So we extract the abstracts and the titles from the dataset that we have. To give you an idea, what we have here is the abstract of the well-known paper, Attention is All You Need. You can see it's, well, roughly the size of a paragraph, and most embedding models, I think, are able to capture this very nicely, so that should be okay. Now we have quite a few abstracts. Let me quickly see how many we have. Over 100,000 abstracts, and with 100,000 documents, of course, we're not going to go through them all individually. Topic modeling is an excellent technique where we can look into those abstracts and see what kind of topics we can derive. Before we can go to Llama 2 and load it in, we actually need to accept its license and make sure that we're logged in into Hugging Face, so it knows that we've accepted it. So if you go to Hugging Face itself and go to your settings and access tokens, you can find the token here. You can copy it, go back to the notebook, simply log in. My token is valid, which is great. It means we can use Llama 2 and then we can continue using the model. So now comes the interesting part, loading in Llama 2 and basically playing around with it for a little bit before we go into the topic modeling. So there are a number of models that we can choose from. We have here the 13 billion parameter variant. I believe there's a 7 billion and 60 billion and at some point maybe a 40 billion parameter model. There's some choices to be made here. And I am specifically choosing now to go with the 13 billion model. And the reason for that is that it's a nice balance between, on the one hand, speed, inference of the model, and also accuracy. So as you might expect, a larger model will be more accurate, but it also requires way more compute power necessary to run the model at a nice pace. So personally, 13 billion is a nice balance between inference and speed, accuracy and speed, but it all depends on your use case. For now, we're using this model, which should be sufficient for the data that we have. Now that's step one. The second step of this loading in Llama is optimization. And that's really necessary because, well, it's a large language model and it really is very large and very difficult to run without doing some extra steps. One of those steps is quantization, where we essentially say, okay, those 13 billion parameters, they are saved generally in a 32-bit representation. But if we compress the 32-bit representation into something smaller, then it will also mean that the resulting model will be smaller. You will lose some accuracy, but depending on the quantization method that you use, it shouldn't be that much. And what we're using here is a 4-bit quantization, where we go from 32-bit to 4-bit, which is quite a big leap in difference. But the performance generally should be okay for this type of model. We're using bits and bytes for that, which is a special configuration, a special library that we can use to do these kind of efficient loading in of models. Well, the number of parameters here, so we loaded in a 4-bit, obviously. We normalize the type of bit. It's what the paper generally uses and also shows very nice performance. There's a small trick that they use. Maybe not small, it's very interesting, where they use a second quantization after the first. And by doing it again, in a way, it further reduces the necessary bits that you will need in order to run your model, which again becomes more efficient. But they've also shown it doesn't reduce the accuracy, so to say, of those models that much. And we say, okay, we want to have, of course, a bfloat 16 during inference, which is generally used for these kind of models. Then we load in the actual model. We have a tokenizer and the model in itself. And the tokenizer is used to go from text to individual tokens. So let's say the word telephone might consist of the tokens tele and phone. Or the word configuration of config and duration. And these kind of tokens are necessary for the model to have some generalized performance, because when it notices a word it hasn't seen before, it can still use those individual tokens to kind of derive what its meaning is supposed to be. We have the tokenizer that we load in, and then we have the model in itself, where we give it the configuration that we created before, so the 4-bit representation, in order to properly load the model. And I've already done these steps because they might take a while. You need to load in a model, things like that, but it loads fine in a T4 instance. This is, of course, where it becomes more interesting because we're slowly approaching the prompt engineering. But before we do that, we use a transformers pipeline. That's a Hugging Face pipeline that makes it much easier to run all of these prompts. And it's also the pipeline that we're going to be using in BERTopic later on. We're setting the number of tokens it can generate. We give it a penalty for how much it repeats certain phrases. We don't want it to repeat stuff. And we set the temperature low. And the temperature basically shows you how, let's say, creative the model is. by lowering the temperature, it's not that creative, which we actually need for this specific instance, because, you know, we're creating topics, and the more creative it becomes in representing the topics, the less accurate it will actually be. So we want to lower the temperature as much as possible. Now for the fun part, prompt engineering. So let's see how all of this worked. I already created this prompt, but let's run it again. Could you explain to me how 4-bit quantization works as if I am 5, which is the Eli 5 representations, or the Eli 5 question that you often see in tutorials. Explain it like I'm 5. And as you can see, it actually takes a while to generate the response. And that's what happens with these kind of models. They are quite large. You need very big GPUs to make sure they run in seconds or even in milliseconds, which is also why you will see in OpenAI is that you don't immediately see the output, but tokens generated one after the other. So it has given us the output, a generated text, and it tries to explain 4-bit quantization with a big box of crayons. And I'm not going through all of this right now, but it's very interesting to read how it tries to explain it using just colors, by basically saying, okay, we can represent something by using 2 colors instead of the color itself. So you can represent orange with red and yellow, so you don't need orange, thereby reducing the amount of crayons that you need. Super fun to read. Llama 2 has a specific template that you need to follow for the specific prompt engineering. It looks like follows. What you have here is a system prompt. That's what you start with. It's how you guide the model into making sure it understands what its use is, or who it should model, or what kind of assistant it should be. It's describing its personality in a way. Then you have your user prompt, where you essentially ask it a question and then you have an answer. And it has certain tags that it was trained on to make sure it differentiates between, okay, this is a system prompt, this is a user prompt, this is an answer, etc., etc. We need to make sure that we follow this template for prompt engineering. As you can see, we didn't do it here. That's because we just asked it a question and didn't do any advanced engineering here. But now that we have this template, let's go a little bit deeper into how we're going to use it for topic modeling. We have here the system prompt. So like I mentioned, that's basically describing who Llama 2 is. And in this case, Llama 2 is a helpful, respectful, and honest assistant for labeling topics. I've kept it simple on purpose just for this tutorial, but we can also extend it to make sure it gives short answers, to make sure it doesn't say anything weird, or you know, how creative it can be, how repetitive it can be, and everything you want into a system prompt. It will take up some of the token space, its token limit. But for now, just this one sentence should suffice into creating the topics that we're interested in. Then we go into the user prompt. And normally we would just ask the question like we did before, right? But this is a more advanced example. And when you're approaching advanced examples, what you want to give it is an output of, okay, this is what I want to see as a result. This is how you should work. So essentially what we want to do is we want to create an example prompt. A prompt that basically shows Llama 2, if you do this, like exactly like it is shown here, then you're doing a good job. This is called few-shot learning, where you give it an example of what it should output. In this case, I have said, okay, I have a topic that contains a number of documents, and these are about meat and their impact on the environment. And then I say, okay, this topic is described by the following keywords. So we have meat and beef, emissions, processed, stuff like that. And then based on the information on the topic above, create a short label. And the label, I think, should be environmental impacts of eating meat. And this is the example that we're going to give Llama 2, so it will become much more accurate when it wants to create, or when it creates labels that we're interested in, that we're looking for. This is a very awesome technique for taking a large language model to the next step. And then we have our main prompt, which is exactly what we did above, this time without specific documents and without specific keywords. Because what we can do here is we can use this tag to put any documents that we want in there for specific topics. So instead of doing the example that we did before, we create a sort of a template that we use each time we ask it for a label for a specific prompt. Or label for a specific topic, of course. So we have the documents that it should get, it should the number of keywords that we give it after topic modeling CTF IDF. And then again, based on the information about the topic above, please create a short label of this topic. And then we will output as a label what we're interested in. Now, then we combine that all into prompt template, so to say, so where we have a system prompt, who is Llama 2. We have an example prompt. This is what the output should look like. And then we have the main prompt, which is essentially our question. Please create a short label of the topic. But what we're doing here is we pairing our embeddings. BERTopic does that under the hood, but we want to do it a little bit more explicit. We want to create the embeddings for our abstracts because we can then more easily use them later on instead of having to recalculate them every single time. And I'm using here a model that's, well, at least that's new with the release of this video and is really high on top of the, let's say, the embedding leaderboard. We're using sentence transformers, which is an amazing framework for loading in a bunch of embedding models. This model really works very well, and it was also just fun using a new state-of-the-art model, state-of-the-art. After we've created embeddings for each of those models, we will define a few submodels. And those submodels will be used within BERTopic. And, well, they will be used automatically, of course, but here we define a few things that we're a little bit more interested in. So UMAP has a tendency to consistently generate new answers if you run it over and over and over. That's not necessarily a problem, but if you want to reproduce your results, we need to set a random state. We also define the clustering model that we're going to be using, HDBScan. We're increasing minimum cluster size, and by increasing it, we will get fewer topics or clusters that are generated. That's something we really want to do because HDBScan has a tendency to generate many microclusters, which can be very interesting, but for the purposes of the tutorial, let's just keep just a few hundred of them. After that, we pre-reduce the embeddings for visualization purposes. What does this mean? It means that we go from embeddings, which are, I think, 700 something in size, just 2 dimensions. And those 2 dimensions are important because I can try as much as I want, but I cannot visualize 700 dimensions. I can visualize 2 though. And with 2, it gives us a proxy for what the embedding structure looks like. And that makes it helpful for us to visualize then resulting topics, their labels, the documents that we can find in them, etc., etc. That's what we did here. Now we go into something a little bit more interesting, the representation models. So we're using Llama 2 to represent topics that we have. We're also using CTF IDF to create keywords, also a representation. Here we're doing a few more representations on top of that. More specifically, keybird, which is a keyword-inspired representation, and maximal marginal relevance, which reduces or increases the diversity of the resulting keywords. Because if we have a topic that has the words car and cars, you know, that's redundant, right? Either remove car or cars. And that's what maximum relevance does. What we get a bunch of representations. And I'm doing this here to show you the difference between Llama 2, Keybird, MMR, CTF IDF, so the keyword-based representation. We can go through them in depth but there's a lot of documentation in the BERTopic official documentation page. But these show you what representations would look like. Now we go into training. I've already done this. It takes, after embedding the models, 15 to 20 minutes. And we pass BERTopic a number of things. So the embedding model that we used to go from abstracts to embeddings. We use the UMAP model to do the dimensionality reduction of the embeddings. The HDB scan model to cluster the reduced embeddings. And then our set of representation models to generate all those different outputs. The great thing about that is that it doesn't just generate one output, it generates multiple. Tremendously helpful when comparing topics, when seeing what a label should be, etc., etc. Because a topic is more than just one perspective of keywords. It can be a label, it can be a summary, it can be a poem, for all I care. It really doesn't matter. It's up to you what you think a topic should represent, of what the thing is that should represent a topic. After training, we now have our topic model, and this is where we can do a little bit more of interactive coding. When we run topic model.getInfo, we will see a data frame. And in this data frame, you will have a number of representations of specific topics. The keyword, the llama, maximal marginal relevance, representative dogs. There's a lot of things happening here. So instead of, a lot of text, a lot of things, let's just go into a few specific topics. And I've chosen one here. What we do is when we run getTopic on the topic model for a very specific topic, so 0 here, it will show us the representations that we can extract. So let's see what happens if we take a look at the main topic. So this is generated with CTF-IDF. And topic 0 then has the keywords, policy, reinforcement, RL, agent learning, etc. And that's clearly about reinforcement, right? But it also has words like to and in, which doesn't really tell you much about the topic. So let's see how MMR has done. It doesn't change the representation that much because it reduces or increases the diversity, and to and in still diverse in a way. They're just not that accurate. Instead, let's see what keyword does. And keyword does a much more interesting representation already. Reinforcement, learning, robots, dynamic, algorithms, model, behavior. These words are much more interesting compared to the words we had before because there were subwords in there. This already describes the topic much better. But there's still keywords, right? There's still keywords that we have to interpret. It can be difficult because now I have to manually assign hundreds of topics that we created. It really does not make sense. So let's see what Llama 2 has created for us. And it has created a very interesting label instead of those keywords. The label here is Deep Reinforcement Learning Challenges. Now, we already saw that it was about reinforcement learning, but now it has created a label for us to interpret, to look at, to view, which also makes communication much, much easier. Because if you're going to communicate keywords to stakeholders, they are going to ask what each and every single keyword means, what those values will exactly mean. And those are important questions. But for a domain expert, maybe not all that relevant. So to have a Llama 2 representation instead that you can show makes communication much, much easier. We can continue exploring topics as we go. So topic 2, audio-visual speech separation and recognition. Those are the kind of labels that you would expect when you do topic modeling, right? Keyword-based is important, but having this additional perspective gives you, as I mentioned, a new perspective. Privacy-preserving federated learning, something I'm working on quite frequently nowadays, but decentralized, distributed, differential. It's indeed about privacy-preserving federated learning. And using all of this, we can explore these topics and we could go in depth in what all of this means. Next, we run this piece of code. And what this is doing, it essentially assigns the Llama 2 labels that we have created to the topics. And this is important because as a default, the labels will be created based on the keywords. And now what we want, of course, is the Llama 2 labels in action. So the last step in this pipeline is to visualize the documents. What we can do is we can run visualize documents with the reduced embeddings that we have. We can use the Llama 2 labels to visualize them, to highlight them, and to even see which documents can be found in these topics. Here we have one about multi-agent reinforcement learning, which obviously is about deep reinforcement learning challenges. We can continue doing this and exploring the interesting topics. We can do adversarial robustness in deep learning. We can do audio-visual speech separation and recognition. If we go over this, we see indeed text-to-speech. We see a lot of speech-like topics, or at least documents that appear here. This allows us to go in depth with topic modeling. Using Llama 2, using these kind of techniques allows us to make topic modeling much more easier, much more intuitive with these kind of labels. Still requires relatively large GPUs, but in the future this will become easier and easier as we go forward. This was BERTopic together with Llama 2, combination that I think works relatively well. If you enjoyed it, if you liked this video, please leave a like or give some feedback. Make sure I do the best that I can. This is a first for me, so any feedback definitely appreciated. If you dislike the video, just dislike it. Also communicate for me what I'm doing well and what I'm doing correctly. Hopefully the videos will get much better in the future. So thank you for watching and to the next tutorial.